Hey guys, so we're going to be working on lesson 4.3 today, working on writing functions. One of the first definitions that you have is what an independent variable is. So here's what we're going to write for that. The independent variable is always the input of a function. The input of a function. And remember that for input, if you scroll back to our notes from yesterday, the input with our little visual right here, input just means the domain or the x's or the independent variable, which is what we were just defining. So if I go back to that, just a little reminder in here, when you're writing the input of a function, just keep in mind that that means the x values, which also means the domain. And then a nice way to remember this is that input is the independent variable as well. So if you want to highlight that or circle that for yourself, you can. The next vocab word that we have is dependent variable, and the dependent variable is then the output of the function. The output of a function. And back to that visual, keep in mind the output is just another way to say the y values of a function or the range. There we go. And then we talked a little bit about function notation in our notes from 4 to day 2 and those kind of fancy picture notes as well, but just kind of a reminder for you guys that function notation is when you see f of x. It's not pronounced f parentheses x, it is literally pronounced f of x. So put a little note there for yourself that says that it's read as f of x, just because that's going to come up quite a bit. And then I kind of want to break down the sentence down here where it says the dependent variable is a function of the independent variable. We just talked about the fact that dependent variable is your is the y values or the outputs of a function. So I'm going to write y in place of that. So y, and then remember that we talked about the word is in math always means equals. So then I'm going to drop an equal sign down here. And then a function of, if I highlight that, a function of, that's where those, that's where that function notation comes into play. So a function of, and then the independent variable right here, if you look up above, is your x's. So then we can put x inside of those parentheses. So the nice part is this is basically telling you that y is the same thing as f of x. So right here, I just kind of want you to point out that y and f of x, they mean the same thing to us. And they mean the same thing because there's an equal sign between them, which means same in math. So sometimes you'll see y equals 2x plus 3, but then other times I could write f of x equals 2x plus 3, and that means the same thing. So if you look at the practice problems for us then, they ask us to first determine a relationship between x and y values, and then we're going to be writing an equation. Before, I've asked you to use a table and a set of points for a couple different things. I've asked you to look at it and tell me whether it was a function or not. And in that case, we were just looking at the x values and just looking to see do they repeat or not. That's not what I'm asking you to do in this problem at all. I'm asking you to determine a relationship between the x and the y values. So you actually have to look at what is happening between the x's and the y's. And if you look at, in this case, from the each x value to the y value, you're looking at what's happening here. So it's going from 1 to negative 2. And then the next time it's going 2 to negative 1. The next time it's going 3 to 0. The next time it's going 4 to 1. Every single time, this is minusing 3. So when we look at that, the relationship is that y is just x, but minus or take away 3. Okay, y is x minus 3. Well, if we break that down into math, y is always means equals, and then we see x Minus literally means a minus sign and then a 3. So our equation then is y equals x minus 3. And that's what we were asked to do here, was write an equation. Now, the same thing that you can do from a table, you can look at it from a set of points as well. We're looking at what's happening from the x values to the y values that go with them. So from 1 to 3, 2 to 6, 3 to 9, and 4 to 12. And guys, it has to be the same thing that's happening every single time. In part A, that table, every single time it was minusing 3. So in part B that we're looking at now, every single time I'm noticing that it's timesing by 3. Every time it's the same, timesing by 3. So one way to summarize that in words is to say that the y value is just the x value times by 3. So the way to write that in an equation then is to write y is always means equals, and then x times 3, I can write that as 3x, or you could write x with a dot and then 3, same thing. But these equations right here are my answers. They are the relationship between x and y. All right. From there, we can look at number 2. And with number 2, it says to identify the independent and dependent variables in each situation. I think the easiest way to do these kind of problems, and I'm going to kind of write this off to the side of your notes here, is to look at using this little system right here. Something in the problem is going to depend on something else. Okay, you'll always be able to say that, oh, this thing depends on this other thing, whether it's temperature and electricity, weight and shipping, or pace and how fast he gets home. Something will depend on something else. What you write in that first blank, that's your dependent variable. And whatever makes sense to go in that second blank, that's your independent variable, because the dependent variable will depend on the independent variable. Dependent variables depend. Okay, so I'll always kind of use that to then identify my answers for the independent and dependent variables. So for part A, it says in the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So I'm just going to put my little blanks in here. Something will depend on something else here. And before I even identify it, this right here, whatever I put there that makes the most sense, that's my dependent variable. And whatever I put here is my independent variable, whatever makes sense to put there. Okay, so if you take a look at this one, in the winter, okay, so I'm using more electricity when the temperature goes down and less when the temperature, so I'm looking at temperature versus electricity in this problem. Those are the two things that I'm kind of like comparing to each other. And I have to think about, does electricity depend on temperature, or is it the other way? Does temperature depend on the electricity? And the most sense for this one is that the amount of electricity that I use, so the electricity that I use will depend on what the temperature is. Because if it's colder, I might turn my heat up and use more electricity, or if it's hot, I don't have to use as much to get my temperature up. I don't have to use as much electricity. So my electricity depends on what the temperature is outside. So I've just identified my two answers here. This is one of my answers. The electricity is my dependent variable, and then the temperature is my independent variable. I'll do that every time. Okay, so for part B, I'll set up my little blank depends on blank. Whatever makes the most sense to put here is my dependent variable, and whatever makes the most sense to put in that second blank is my independent variable. This time I'm looking at the cost of shipping a package based on its weight. So I'm looking at the cost of shipping and I'm comparing it to its weight. So I have to think about, does the weight depend on the cost to ship, or is it the other way? Does the cost of shipping depend on its weight? And they even said is based on its weight, which is the same thing as saying it depends on its weight. So that means that weight is definitely going to go in the second blank because they said based on weight, which means depends on weight. And then the shipping cost I could put right here. So the shipping cost depends on the weight. because I'm going to go to wherever it is, the UPS or whatever, weigh my package, and then that'll help me figure out how much it's going to cost me. So the shipping cost depends on the weight. So here's my two answers. Shipping cost is my dependent variable. Weight is the independent variable. The last one is the faster Ron walks, the quicker he gets home. So again, I'm going to set up my little blank depends on blank. Whatever makes the most sense to put in that first blank is my dependent variable. The second blank is my independent variable. So I'm talking about how fast Ron walks and how quick he gets home. So let's see, does how quick he gets home depend on how fast he walks? Or does how fast he walks depend on how quick he gets home? And I would say that how fast he gets home, so the quicker he gets home, how fast he gets home, so I'm going to write how fast gets home. I'm just kind of paraphrasing there. How fast he gets home depends on how fast he walks. And there's different ways that you can say this. Like I could have said how fast he walks, that's like his walking pace. So I could have written walking pace right there if I wanted to. But you can use the words in the problem or use something similar, but you have to make sure that how fast he gets home is depending on how fast he walks. Okay? So the dependent variable is how fast he gets home. Next one, number 3, is asking to identify the independent and dependent variables and then write a rule for the situation as well. So we're actually kind of doing 3 things here. We're identifying the variables, independent and dependent, and we're writing a rule in function notation. All right, so it says a lawyer's fee is $200 per hour for her services. So I'm going to go ahead and set up my little blank depends on blank here. And I'm looking at the lawyer's fee is $200 per hour for her services. So I'm comparing the lawyer's fee to like how many hours they ask for her services here. So I think that the fee would definitely depend on how many hours you use the lawyer for. And remember, whatever you put in that first blank is your dependent variable. Whatever you put in that second blank that makes the most sense is your independent variable. There's only one right answer there. You just have to figure out which one depends on which. The fee, how much she charges you, will depend on how many hours she works for you. And then we were asked to write a rule for this as well. So the rule, if it asks for it in function notation like it does up there, function notation means that you have to write f of x equals instead of y equals. Like you guys are used to doing y equals something, but function notation means you got to have f of x. If you don't, you'll get minus a half. And then, let's see, we know it's $200 per hour for her services, but that's all we know. So $200 is a number that I have per hour. Per in math means multiply. So I'm going to times by. And the hours, we don't know, so we're going to call it x. We have no idea how many hours she's going to give for her services there. All right, so f of x equals 200 times x. The next one, we're doing the same thing. We're identifying the 2 different types of variables, and then we are also writing the rule. So first of all, we have to figure out what depends on what here. So blank depends on blank. Whatever I put here that makes the most sense will be my dependent. Here is my independent. And this time we're comparing, let's see, the admission fee to a local carnival is $8. Each ride costs $5. So we're looking at like the fee, and we're comparing it to, well, they're going to charge us $8 no matter what. So, and then I'm looking at like the number of rides that we go on as well. So for this one, the fee, how much I pay altogether, will depend on how many rides I go on. Okay, so how much I pay will depend on how many rides I go on, because if I go on more rides, my fee, my cost is going to be higher. So then writing the rule in function notation means you better start with f of x equals, and then we can start thinking about, okay, I know that right off the bat, the first number they give me is 8. It's going to be $8 no matter what. Plus, I'm going to be going on rides. And so plus, I'm going on each ride is $1.50. So $1.50 each. And so each means I don't know how many times I'm going to do it, but it means I'm going to multiply. We don't know how many rides, that's our x. So it's 8 plus 150x for the function. F of x equals 8 plus 150x. So kind of combining the idea of independent and dependent variables with writing equations in math and getting used to those each means times, per means times, and kind of those English words that mean certain things and math words that we've been discussing. All right, next problem is number 4, where we're evaluating functions. And we talked about the word evaluate in our notes the other day. If I scroll up here, evaluating, if I zone in right here, evaluate really just means plugging something in. All right, that's all it means. So you take a number and you plug it in and you solve it. So if I go back down to our notes for today, where we're evaluating here, we're going to do this for A, B, and C. I want you guys to circle or highlight the word evaluate, and off to the side, just write a little note that all that means is that you're going to be plugging something in. That's it. Okay? And they'll tell you what to plug in. Like in this example for part A, we have our function, and then they give us that we want to plug in x is 6 and x is 7.5. So we're plugging in more than one thing for this. Okay? So we just have to use our function that we were given right here, and we're going to plug in an x value of 6, so I'm going to write f of 6 equals, and then 5 multiplied by, since it's smushed by, and then in place of that x, I'm going to plug in the 6 that they asked me to use. You don't do anything with the f of 6. Okay, that's just saying the function of 6 equals, but if you type 5 times 6 in your calculator, you get 30. So that is what f of 6 equals. It equals 30. Now, on the other hand, we have to also plug in f of, they're asking us to also do 7.5. So f of 7.5 equals, the function is 5 times that x number. So for us, we're again doing 7.5. And if you type 5 times 7.5 in your calculator, f of 7.5 equals 37.5. And there you go. So those are my two answers because I evaluated two different values. I evaluated 6 and also 7.5. Next one, guys, we're going to be plugging in. You can see they want to know what happens when t is 2. And then that should not say x. That should say t is negative 5. So we can plug both of those in. So now when I go to use my function right here that they gave me, functions are just equations, I'm going to plug in 2, so I'm going to do g of 2, and all that means is I'm going to plug 2 in for the letter t. So 2.30, plug in 2 for that t, and add 10. When you type that into your calculator, you get that g of 2 equals 14.6. And that's one of your answers. Okay. From there, they also wanted us to plug in negative 5. So I'm going to take that equation, g of, I'm going to plug in negative 5 equals 2.3, parentheses, I'm plugging in negative 5, and then plus 10. And when you type 2.3, parentheses, negative 5, add 10 into your calculator, you get that g of negative 5 equals, all of that is negative 1.5. And that's your answer. So remember, evaluating is just plugging in. The last problem, I'm sure you could do this on your own by now, is just taking 12 and plugging it in, and then negative 8 and plugging it in. So we're going to take the function that was given to us this time, a little messier just with the fractions. And first we're going to plug in 12. So 1/2, parentheses, I'm plugging in 12 in place of that x, and then minus 3. When I type that in my calculator, half of 12 is 6, take away 3 is 3. So h of 12 equals 3. Next one, you can type in h, we're going to plug in -8 this time. So I'm going to do half of parentheses -8, and I'm going to minus 3. When you type that in your calculator, half of -8 and minus 3, you should get -7. So there's your other answer. So that's evaluating a function. It's already given to you. You've got different values. You just have to plug them in. Okay. Last one here, guys, before we go, is number 5. And it says Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function rule to describe how much money Manuel can collect from selling tickets. Find a reasonable domain and range for the function. A reasonable domain and range for the function. That's going to be key here. The other thing that we were asked to do up above here, guys, is write a function rule. So you guys have been doing that already. Okay, you guys did that up above in number 3, where you had to write the equation off to the side in function notation. Okay, function rule means that you're going to start right away with f of x. Okay, that's what it means to write a function rule. So from there, f of x equals the first amount that I see is that he already sold $20. So he already is making $20. And he has 4 tickets left to sell, but they're $2.50 per ticket. We actually don't know how many he's going to sell. We just know that he has 4 of them left to sell. So he's got $20 made already, plus he's going to make $2.50 per each ticket that he sells. Per in math means you're going to multiply. And even though he has 4 tickets altogether, we don't know how many he's going to sell. So that's our x, our unknown thing. So 20 plus $2.50 per ticket. We just don't know how many he's going to sell. That's our function rule. This is part of your answer right here. And then we needed a reasonable domain and a reasonable range. So here's the deal with domain and range. Remember that domain is always your x's and range is always your y's. For us, our x right here, x stands for the number of tickets that he sells because he makes $2.50 per ticket. So in the range is going to be like what you get out. So for us, that's our y's. But remember, y means the same thing as f of x. So domain is our x's that are reasonable. Well, we only have 4 tickets. So here's the deal. Manuel can either sell 0 tickets. That's a possibility. He could sell 1 ticket. He could sell 2 tickets or 3 tickets or 4 tickets. But he can't sell a half or 2.5 or 3.5 or anything like that. He can't sell -1 or -2 tickets. And he certainly can't sell 5, 6, or 7 because he doesn't have that many left. So the only domain values that make sense are 0, 1, 2, 3, and 4. The range comes from putting those in. So if I wanted to actually put those in, if he sells 0 tickets, he's not going to make any more money than he already has. So 20 would be a possible range value. Like he would just make $20 and that's it. But if he sells 1 ticket, if I plugged 1 into there, I would type in my calculator 20 plus 250, plug in 1 there. Then 20 plus 250 is 2250. That's a reasonable output from selling 1 ticket. We could also potentially sell 2 tickets though. So if I plugged in 20 plus 250 times 2, well, I know 250 times 2 is 5, and add 20 to that, that's $25 that Manuel would make. 25 is a reasonable output from selling 2 tickets. He could also sell 3 tickets though, so 20 plus 250, plug in 3. That would be, if you plugged it in, $27.50. And then lastly, he could sell all 4, which is 20 plus 250 times 4. And that would be, let's see, $30. Okay, and that's from selling 4 tickets, but that's all. He's not going to make less than 20 or more than 30. He's not even going to make like $21 or $26 because that's not a possibility from how many tickets he has and what those costs are. So my domain and range right here, reasonably, are these values and those values only. That's it for today's notes, guys. Hopefully that went well, and I will be back tomorrow and see you guys then.